This is an old Corvette engine. I mean, it's in a Mazda, but don't worry about that. It has an old school, cable driven, metal rotating plate style throttle. You would expect it closed to be closed, wide open to be wide open, and halfway to be about 50% of your air. But that's not the case. Half of this opening, so that would be 0 degrees, 90 degrees. You'd expect 45-degree opening to be half of your air, but that's not the case. If this was a sliding door type of throttle, that would be the case, but it's not. It ends up being about 70 to 75% of your theoretical airflow. How do we fix that? Nowadays, you would have an electronic motor right here, and then you wouldn't have an actual physical linkage to your gas pedal. So the sensor in your gas pedal could tell this thing to do whatever it wants. The computer is controlling it. It's really cool because you could actually filter out jerky movements. So like say you hit a bump and your foot kind of wiggles the gas. Modern cars could just filter that out. But this thing, if you move it, it's moving. Then you have a direct input to your engine. But check this out. This is not a circle. Most throttles you would expect a circle pulley that just looks like this. So it's the same amount of movement whether you go from 25% throttle to 100% throttle. It's always the same amount of rotation. But Chevy, and I am sure other big engines do this, but Chevy thought up this really cool method of using a non-standard, non-circular throttle pulley. So look, check this out. At closed throttle, so say you're making this a tiny little movement, you have a lever arm this long. Your cable is acting on a lever arm, I don't know, about 2 inches long. But say you go wide open throttle, so from here to here, now your lever arm is actually only about half of that. So small little movements at, 80 to 90% throttle are actually way bigger opening angles on your throttle plate. This means that when you're driving in traffic and making tiny little movements with your gas pedal, you're making only the tiniest little opening. Check this out. Okay, now I'm in the car and I'm going to show you exactly what different throttle amounts on my end give on the engine's end. So if I make I don't know, say I'm starting out at a light, it's a manual car, so I need a lot of control over this engine. I'm going to give it about this much gas. This is about 5 to 10% throttle. Look how tiny that gap is around the throttle plate. That is so small. And yet, because it's a big old V8 engine, that is plenty to get going. In fact, it's even still just a bit too much. Full throttle is, of course, full throttle. But look, if I go about halfway with my gas pedal, that flap isn't halfway open. It's less than that, but it gives me roughly, according to the engineers, it gives me about 50% of my theoretical airflow. It's just such a simple, elegant solution to a really complex problem, and I love it. That is modern engineering at work. Well, actually, that's like old school engineering, but still, I love it.